All right, I'm here to talk to you quick about Bill's fence problem. This is in class kick, so you should have worked through this, but I also just want you to double check in on it, make sure that you're good to go because we are going to be doing a graded version of this later in class, later this week in class. So Bill's fence, he's building a new vegetable garden. He has a budget of 500. The city ordinance limits him. So if we look at him, the maximum height of any fence built on commercial property is 8 feet. All homeowners have a maximum height limit of 7, though. So these requirements are to be complied with by all citizens. So for Bill, when we're looking at the first question here, it says write an inequality of the possible heights for Bill's fence and plot it on a number line. Because he's a resident and it's a residential house, he has to abide by that maximum height of 7. So maximum signals to us that we have less than or equal to 7. So we're going to go ahead and put a closed circle on 7 here. The only other thing that I want to include is if we have a fence, we're not going to be negative. So no negatives here. So to represent that, what we can do is we can say that x, which is the height of our fence, has to be greater than or equal to 0. So we would put that dot right here. The shading for this would go up to the right, but the shading for this would go down to the left. So because we're looking at a real world situation, we're going to actually just shade in between these two here because that's going to represent that our height has to be a positive number or 0 if there's no fence, and our fence can go up to being 7 feet tall. Number 2, Bill's garden is a perfect square and has an area of 49 square feet. So his area is 49. How many feet of fence does he need? The feet of fence part is going to be going around the outside. So we call that in math, that's our perimeter. So if we have our area, we need to figure out how long the sides are. If you remember when we first started talking about square roots and we were talking about squares, we could take the square root of the area and that would actually give us the length of the side. So the side is equal to the square root of 49, or 7. So going around the outside, all of our sides would be 7. Perimeter of this square is going to be 4 sides that are 7 each. So our perimeter is going to be 28 feet. So he would need 28 feet of fence in order to go all the way around the outside here. I'm going to go ahead and move to the next part of the problem. Yours is on the same screen. Mine is on 2 separate ones, though. So the cost for each fence is listed below for each foot. Keep in mind from just before we found out that he needs 28 feet of fence. So when he needs 28 feet of fence, we can only pay a certain amount of money in order to keep him in his budget. The budget signals to us that our cost has to be less than or equal to $500. So we're going to buy 28 feet of fence at X dollars per foot. So our X represents the cost per foot. So if I solve my inequality, I'm going to divide by 28 on both sides. And I get X is less than or equal to, normally we would round up. Because this is money though, I'm going to actually just keep it at 17.85, just so that we're a little bit more accurate. Because if we round it up, that could potentially put us over our budget here. So we want to play it safe here. So the 8-foot tall fence is actually not allowed by ordinance anyway. 7-foot tall fence is $27, so that can't work because we can only spend $17.85. 6-foot fence is out, 5-foot fence is out. It looks like this 4-foot or even the 3-foot fence would be good here. So it says, what is the tallest fence he can get? So his tallest fence is 4 feet. And Bill wants to know why this is the tallest fence he can buy, and it has to do with his budget. So his budget actually limits him here. So his budget limits the height. And since he needs 28 feet, that's the highest fence that he can actually purchase. So that's Bill's fence for you. We are going to be doing a graded example of this later on in class later this week. So I just wanted to be able to go over this one with you so that you knew what was going on.